Cell phones, tablets, laptops, cameras, electric cars, scooters, portable chargers, Bluetooth speakers, marine batteries, solar panels, RV batteries, golf carts, pacemakers, watches, thermometers, remote car keys, laser pointers, hearing aids, calculators, remote control toys, gaming controllers, and vaporized nicotine devices. You may know what a lithium-ion battery is, but did you know just how essential they are to your daily life? Living without them would mean sacrificing our favorite devices, the products that we rely on every day for work, entertainment, transportation, medical care, and so much more. But what's the issue here, and why are we asking you to possibly lessen your dependence on these devices? That is what we hope to show you by illuminating just how they are made and how they are discarded. First though, why exactly have these tiny pieces of technology become so inseparable from our modern society? It's all due to their size, efficiency, and storage potential. The power of lithium was first recognized by a Stanford University chemist, Stanley Whittingham. He was recruited by Exxon in 1972, where he discovered something astonishing. He found that using lithium as an anode resulted in a higher voltage storage potential than any available commercial battery at the time. However, due to lithium's high reactivity, he deemed it too reactive for commercial usage. The next development was made by an Oxford University professor, John Goodnow. His research made significant contributions to the positive portion of the lithium-ion battery, the cathode. By utilizing a different cathode, he doubled the storage potential of the lithium-ion battery. The battery was finally developed into a commercially viable product by Akira Yoshino of the Asahi Kasei Corporation in Japan. The scientists experimented with many carbon-based casings to produce a stable and rechargeable high-voltage battery. The final piece of the puzzle was a byproduct of the oil industry, petroleum coke. The three scientists were awarded the Nobel Prize for Chemistry for their achievements in 2019. How does a lithium-ion battery work? The battery contains many cells, each containing a cathode, anode, and a separator, which acts as a conductive electrolyte. The anode is usually made of copper foil with a thin layer of carbon on top, whereas the cathode is made of aluminum, cobalt, and lithium metals. Lithium ions move within the cell through the electrolyte, causing electrons in the external circuit to move between the electrodes in the opposite direction. The movement of electrons in the circuit is what provides the current used to charge and discharge the device. When the battery discharges, lithium ions are released by the anode and received by the cathode. When the battery charges, the opposite occurs. Lithium ions are released by the cathode, which are received by the anode. Sounds amazing, right? The way these devices revolutionized our lives and kickstarted multi-billion-dollar industries. But rest assured, they are certainly not without their pitfalls. Since the discovery of the lithium-ion battery, there has been an incredible burst in their demand. The growing concern for global warming caused by fossil fuel emissions has led to a shift towards renewable energy, thus the need for lithium. The global production of lithium almost doubled from 2016's 38,000 metric tons to 2017's 70,000 metric tons, and in 2021, global production was 100,000 metric tons. To put this in perspective, the average weight of a male African elephant is 6.8 metric tons. That's 14,706 elephants. This increase in mining efforts has had catastrophic effects on ecosystems and people around the globe. In countries like Chile, Argentina, and Bolivia, the most common method of lithium mining is brine mining, in which water is pumped up from the underground aquifers and then evaporated to leave behind lithium. This method not only depletes local water resources, but also contaminates groundwater with chemicals used in the mining process. It leads to otherworldly looking mining operations like those shown here, and because these operations mostly take place in largely unregulated countries, locals are powerless to stop these massive corporations from depleting and contaminating their water. The cobalt used in the cathode of the batteries isn't much better when it comes to ethical extraction. In the Democratic Republic of Congo, the source of 60% of the world's cobalt, child laborers and locals work long hours in unsafe mines, breathing cobalt dust into their lungs and working under constant threat of mine collapse. That's just the problems relating to lithium and cobalt production. The nickel, iron, aluminum, and manganese found in the batteries also requires mining, extraction, and refining, a demand that increases carbon emissions, waste, and demand for cheap labor in these unregulated areas. That is just the problems relating to the production of lithium-ion batteries. An equally pressing issue facing our future dependency on these devices is how we will recycle and dispose of them. With the lithium-ion battery industry set to grow from 100 gigawatt hours of annual production in 2017 to almost 800 gigawatt hours in 2027, it's clear that in the future we will have more and more batteries to dispose of and recycle. One Tesla Model S alone, for example, has about 12 kilograms of lithium in its 18,650 cell 100 kilowatt hour kWh battery. If these batteries aren't recycled, they're likely to end up in landfills where toxic heavy metals like cobalt, manganese, and nickel can leak into the environment. The batteries can also cause fires within the landfills, releasing toxic chemicals into the air. Because lithium cathodes degrade over time, they cannot be simply placed into new batteries, and currently there's not a foolproof way to recycle all the metals still within the used battery cells. Methods using solutions of chemicals and even bacteria to process the metals are being investigated, but currently the most common method is pyrometallurgical, essentially shredding and burning the batteries, a process that wastes a lot of the lithium. Currently, only 5% of lithium-ion batteries are recycled. It is essential that we find ways to recycle these batteries, as this will lessen the demand for new mining operations and new lithium extraction, as well as reduce the carbon footprint of these production processes. Recycling will also lead to less wasted battery cells ending up in landfills, which means less toxic metals in our air and water. Lithium-ion batteries have the potential to aid an energy revolution, but only if we're mindful of the cost of their production and disposal.
Thanks for watching!